Good morning, all of you. Welcome to Sri Jayendra Rank Zone. In the last lecture, we have completed D and F D block elements, only theory part. Now, in this session, we are going to do questions based on D and F block elements and some important points regarding D block elements. So, all of you note it down properly in your classwork. Let us start now. Some more important points of D block elements. Then we'll do questions based on the entire chapter. Now, coming to important points regarding D block elements. Even though the ground state of the atom has D10 configuration, this is the final summary of the chapter. So, even though the ground state of the atom has D10 configuration, palladium and coinage metals like copper, silver, and gold behave as typical transition elements. This is because in their in their most common oxygen states, copper has D9 configuration, and palladium 2 and gold 3 has D8 configuration. That's why they are called as typical transition elements. What are typical transition elements? Palladium, copper, silver, and gold. This type of questions also they may ask in the entrance exam. So, so copper 2 has D9 configuration because copper atomic number is 30 as we already know. So copper configuration is 4s2, 4s1, 3d10. So copper 2 configuration is, copper 2 means plus 2 state. So one electron from s orbital and one electron from d orbital will go off. Then this becomes 3d9. So copper 2 has D9 configuration in their most common oxygen state. Palladium 2 also and gold have D8 configuration. These are called as typical transition elements. Even though the ground state of the copper atom has D10 configuration, palladium and coinage metals like copper, silver, and gold are considered as typical transition elements. Typical transition elements. So which are the following typical transition elements means? Then give the options palladium, copper, silver, and gold. Next continuation. It is possible to determine the thermodynamic stability of the transition elements based on ionization energy values. So based on ionization energy values, we can determine the thermodynamic stability of the transition elements based on ionization energy values. So for nickel, it is ionization energy 1 plus ionization energy 2. What is mean by this IE1 plus IE2? The amount of energy required to remove first electron and second electron. Total, it is equal to 2490 kilojoules per mole. And IE3 plus IE4 is equal to 8800. So it is more stable in plus 2 state. By this, you can easily understand it is more stable in plus 2 state rather than plus 3 and plus 4 state because the ionization energy 3 and ionization energy 4 is equal to 8800. So total it is coming around 11290. Whereas for platinum, first ionization energy, second ionization energy is also 2660 joules. So it is more stable where compared to 6700 for IE3 and IE4. So total it is coming around 9360. By this, what you can understand, nickel 2 compounds tend to be thermodynamically stable than platinum 2, while platinum 4 compounds are more stable than nickel 4 because platinum 4 compounds are more stable than nickel 4 elements. Continuation. Very, very important. Chromyl chloride test. What is chromyl chloride test? We are going to discuss now. Chromyl chloride test is used to identify chlorine ions in inorganic salt analysis. This salt analysis we'll do it in 12th class. So in this class only, in this year only. So what is chromyl chloride test? It is used to identify chlorine ions. Manganate ion, that is Mn, permanganate ion, that is MnO4 minus, has 3d0 configuration because all the 7 electrons in manganese are removed. So that's why as manganese is in plus 7 state, so all the 7 electrons in the manganese is removed. So that's why it has 3d0 configuration. Pink color arises due to charge transfer phenomenon by oxygen atom to manganese. Actually, 3d0 means all are paired. So all are paired means what happens here? It comes to argon configuration. Manganese will come to argon configuration, but still it is showing pink color because due to charge transfer phenomenon by oxygen atom to manganese. Thus, one of the oxygen atom is O minus, and manganese changes from plus 7 to plus 6. So next point is sodium ferrate ion, that is Na2FeO4, has Fe plus 6 and is a strong oxidizing agent. So the oxygen state of ion is plus 6 state. So Pu plus 4, Pu plus reduction, and Pu plus 4, PuO2 plus is oxidation. So this important point in this is, even though manganate ion, that is MnO4 minus an ion, has 3D0 configuration, still it is colored because it is due to charge transfer phenomenon by oxygen atom to manganese, and it is paramagnetic because one of the oxygen atom is O minus out of MnO4 minus. Next, potassium permanganate preparation. Again, the important reactions we have done. So potassium permanganate, it is manufactured by fusing pyrolusite. Pyrolusite means manganese dioxide, that is MnO2. MnO2 with potassium hydroxide or potassium carbonate to form green potassium manganate, that is K2MnO4. This is called green color. So this green color changes to purple color finally. So green color. It is oxidized to potassium permanganate using chlorine or ozone gas. So potassium manganate on reaction with chlorine gas, it forms potassium permanganate plus potassium chloride. Potassium manganate plus water plus ozone gives rise to potassium permanganate plus potassium hydroxide plus oxygen. It is also prepared by the electrolytic oxidation of potassium manganate. So these are the three preparations of first preparation, second preparation, third preparation of potassium permanganate. Next continuation. Properties of potassium permanganate on reaction with concentrated sulfuric acid. It gives the explosive oil-like substance called Mn2O7. This is called explosive oil-like substance. So potassium permanganate in acidic medium forms Mn2O7 plus K2SO4 plus H2O. When warmed carefully with concentrated sulfuric acid, oxygen is produced. Very, very important reaction. In one case, in the first case, it is producing Mn2O7 and water. In the second case, it is producing manganese sulfate and oxygen gas. So it burns on heating with hydrogen. Potassium permanganate burns on heating with hydrogen and forms potassium hydroxide, manganese oxide, and water. So these three reactions are important. In the previous session, we have discussed only ionic reactions of potassium permanganate. Now we are discussing some more important reactions of potassium permanganate. So all of you please note it down. As we already know, potassium permanganate is a powerful oxidizing agent in acidic, basic, or neutral media. These reactions we have already discussed in the last session, but here we have discussed complete reaction. There we have discussed MnO4 minus plus OH minus like that. So here we are discussing complete reaction. You can just see these complete reactions are important for our objective exams. So potassium permanganate in neutral media, that is with water, it forms potassium hydroxide, manganese dioxide, and oxygen, three nascent oxygens. So since it is giving base in neutral media, and potassium permanganate on reaction with potassium hydroxide, that is basic media, it forms potassium manganate, water, and nascent oxygen. And potassium permanganate along with sulfuric acid forms potassium in acidic media. It forms potassium sulfate, manganese sulfate, water, and oxygen. All these three reactions are very, very important. Please note it down in your class. So these are the complete reactions. In the previous session, we have done only ionic reactions, that is half reaction. Now in this session, we are giving complete reactions. So please note it down in your classwork. That's why I have not written complete reaction in that class. In acidic medium, it oxidizes oxalic acid to carbon dioxide. Oxalic acid formula is C2O4 2 minus. Oxalic acid is H2C2O4. It reduces oxalic acid because the oxygen state of carbon is plus 2 and here it is plus 4. So it oxidizes oxalic acid to carbon dioxide, ferrous to ferric, hydrogen peroxide to oxygen, hydrogen sulfide to sulfur, iodide to iodine, hydrogen halides to halogens, sulfur dioxide to sulfuric acid, and nitrates to nitrates. All these reactions in the previous session we have discussed. So please kindly note that reactions. So in acidic medium, potassium permanganate is a strong oxidizing agent. It oxidizes oxalic acid to carbon dioxide, ferrous ion to ferric ions, hydrogen peroxide to oxygen, hydrogen sulfide to sulfur, and iodides to iodine, hydrogen halides to halogens, and sulfur dioxide to sulfuric acid, and nitrates. Nitrates formula is NO2 minus. So it is changed to nitrates, that is NO3 minus. In basic medium, it oxidizes potassium iodide to potassium iodate. This reaction already we have given. And toluene to benzoic acid. Toluene formula is C6H5CH3. Toluene to benzoic acid C6H5COH. So manganese potassium permanganate oxidizes toluene means methylbenzene to benzoic acid. Cold dilute alkaline KMnO4 called as Bayer's reagent. What is Bayer's reagent? It is called as cold, dilute alkaline potassium permanganate oxidizes alkene double bonds to vicinal diols. Vicinal diols means at the end double bonds will be present. So these reactions will show you too. In organic chemistry, we'll be studying those reactions. So potassium permanganate is an orange red color crystalline solid soluble in water. In solutions, dichromate ions Cr2O7 minus exist in equilibrium with chromate ions, that is CrO4 2 minus, as follows. So orange color in equilibrium with yellow color of chromate ions. So dichromate ion is in equilibrium with chromate ions. In alkaline solution, equilibrium shifts in the forward direction. Very, very important point to be noted. So dichromate ion changes to chromate ions, and the solution is yellow in color because due to the formation of chromate ion. The same question they'll ask. In alkaline solution, potassium permanganate changes to yellow in color. This is due to the formation of chromate ion. This is due to the formation of chromate ion. Whereas in the acidic medium, equilibrium shifts in the backward direction and the solution is orange. So in the acidic medium, potassium permanganate becomes yellow in color, orange in color, yellow color changes to orange in color because due to the formation of dichromate ions. So this conversion takes place with the change in pH of the solution. First is in forward direction, it is equilibrium shifts in the forward direction, the solution is yellow. So in basic medium, it changes to orange color changes to yellow, and in acidic medium, yellow color changes to orange. So these two conversions are very, very important in the objective exam. So for dichromate ion in basic medium changes to chromate ion yellow color, and chromate ion in acidic solution in acidic medium changes to dichromate ion, that is orange color. So these two shifts are very, very important. Please note down in your classwork. Definitely they'll ask based on this question. So in alkaline solution, potassium that is dichromate ion changes to yellow in color due to the formation of chromate ion. And in in acidic solution, in acidic medium, chromate ion changes to orange color due to the formation of dichromate ion. And these two are in equilibrium with each other. These two are in equilibrium with each other. So it is clear. Next conclusion. So it decomposes to chromium oxide on strong heating. Potassium dichromate decomposes to chromium oxide on strong heating. Potassium dichromate decomposes to chromium oxide on strong heating. And chlorine is formed on heating with constant HCl. Potassium dichromate on heating with constant HCl. It forms potassium chloride, chromyl chloride, along with chlorine and water. This is called chromyl chloride test. This reaction represents chromyl chloride test. Chromyl chloride test. What is chromyl chloride test? When potassium permanganate is treated with constant HCl or acidic medium, it forms a greenish yellow color gas is formed due to the formation of chlorine gas. So a greenish yellow color gas, greenish yellow color gas is formed due to the formation of chlorine. That confirms chlorine is present in the compound. So this is called greenish yellow color gas. So to confirm whether a compound is containing, so whether it is chlorine or not, we have to react with potassium dichromate along with HCl. It forms chlorine gas. So this is called chromyl chloride test. Chromyl chloride test for the identification of chlorine gas. Continuation now. Potassium dichromate is a powerful oxidizing agent in neutral media as well as in acidic media. So potassium dichromate on reaction with water, that is in neutral medium, forms potassium hydroxide, chromium hydroxide along with nascent oxygen. Potassium dichromate on reaction with sulfuric acid, this is acidic media, it forms chromium sulfate, chromium hydroxide and chromium sulfate. So it oxidizes ferrous ions to ferric ions, hydrogen sulfide to sulfur, same like potassium permanganate, sulfur dioxide to sulfuric acid, and potassium iodide to iodine. So potassium dichromate and potassium permanganate are good oxidizing agents. So they can oxidize iodides to iodine, hydrogen sulfide to sulfur, sulfur dioxide to sulfuric acid, ferrous to ferric salts. Continuation now. Chromium chloride test of chlorides. As I told you, this is called chromium chloride test reaction. So potassium dichromate on reaction with sodium chloride in acidic medium forms potassium bisulfate, sodium bisulfate, along with the formation of chromium oxychloride, oxychloride. CrO2 Cl2 on reaction with sodium hydroxide forms sodium chromate along with sodium chloride along with water, and this sodium chromate, on reaction with lead acetate forms lead chromate precipitate along with sodium acetate. So this is called chromyl chloride test of chlorides. Very, very important. Definitely they'll ask in the examination. So please remember, this is very, very important. This slide is very important. Note down continuation of this slide. Action of concentrated sulfuric acid in cold, red crystals of chromic anhydride CrO3 are formed, and CrO3 is highly acidic and is called chromic acid. On heating, oxygen is evolved. So potassium dichromate in an acidic medium, it forms oxygen gas. Potassium dichromate in acidic medium, it forms oxygen gas. Now, potassium dichromate on reaction with hydrogen peroxide. Acidified solution of dichromate ions forms a deep blue color. These tests are very, very important. So forms a deep blue color with hydrogen peroxide due to the formation of peroxo compound, that is CrO2 taken twice or CrO5. Very, very important. So acidified potassium dichromate solution forms a deep blue color solution with hydrogen peroxide due to the formation of peroxo compound, that is CrO2 taken twice, CrO2 taken twice. It's a complex compound, or simply CrO5, chromium pentoxygen. And the blue color fades away due to the decomposition of CrO5 to Cr plus 3 and oxygen. And finally, this blue color solution changes to its fade. Fades means no color, colorless, due to the formation of CrO5 to changes to Cr plus 3 and oxygen. The structure of CrO5 is like this, in which chromium is in plus 6 oxygen state, CrO5. Here it has peroxy bonds. In CrO5, how many peroxy bonds are there? 1, 2, 3, 4 peroxy bonds. Very, very important. In CrO5, chromium has, please note down this point, has 4 peroxy bonds. 4 peroxy bonds with oxygens, with oxygen atoms. Only one double bond, remaining all peroxy bonds, CrO, 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 CrO. So this is 4 peroxy bond, and oxygen also peroxy bond. And here, so that's why this oxygen state is plus 6. Actually, if you take -2 oxygen state of oxygen, it will come plus 10. Plus 10 is not possible, only plus 6, because due to the presence of peroxy bonds, chromium has 4 peroxy bonds with oxygen atoms. So that's why it is called, so CrO5, it is plus 6 oxygen state, plus 6 oxidation state. Continuation. This point is very important. Please note it down. Now we are going to discuss questions based on complete D block element chapter. Then afterwards, finally, I'll give summary of the chapter, so that what you are going to study in this chapter, I'll be telling you clearly. And please follow that and do it 100% D block elements. You will get one question for entrance exam. So what type of questions we are going to get, that we are going to discuss now. So now question number 1. Fusion of chromite ore with sodium carbonate or with oxygen gives. Very, very important question. The fusion of chromite ore with sodium carbonate and oxygen gives yellow color of sodium carbonate, sodium dichromate, yellow color sodium chromate, orange color sodium chromate, and chromium oxychloride. Fusion of chromite ore with sodium carbonate. So answer is yellow color of sodium chromate. It is forming due to the formation of sodium chromate. Chromate O is forming, that is CrO3, it's changing to chromate Na2CrO4 by the action of potassium dichromate. Very, very important question. This is, please note it down. All the best questions we have given here for the examples. So you please note it down, all these questions. Next, when acidified potassium permanganate is added to potassium iodide, potassium iodate is formed, iodine gas is released, manganese dioxide brown solid is formed, MnO4 minus changes to MnO4 2 minus. MnO4 2 minus is +7 changes to +6. So in acidic medium already we know potassium permanganate changes from plus MnO4 minus changes to Mn plus 2. So this is not possible. So, and already we know potassium iodide is oxidized to iodine. Iodide is oxidized to iodine. So answer is, for this question, what is the answer? It could be iodine gas. Whereas in neutral media, potassium iodide, basic media, alkaline media, if you take the same reaction in alkaline medium, when potassium permanganate, alkaline potassium permanganate is added to potassium iodide, it changes to potassium iodate. This is formed. First option will be formed. But here, this is acidified potassium permanganate, means it is nothing but acidic medium. So when acidified potassium permanganate is added to potassium iodide solution, iodine gas is released. Next question. Copper sulfate, hydrated copper sulfate on strong heating at 573 kelvins gives, it forms copper sulfate because it removes water of crystallization. So this will be evaporated. So it forms copper sulfate. Among the following, identify the species with the metal atom in +6 oxygen state. +6, here it is +7. Easily we can see because x minus 8 is equal to -1. First one I'm solving. Let us take manganese is x. So x plus -2 into 4, because oxygen is -2 into 4 is equal to -1. So it implies x is equal to +7. That is first one I have shown. Like that you can do for second, third and fourth also. Chromium, Cn6 and 3 minus, here it is already given. So this is x and cyanide is +1 -1 plus -1 into 6, because each cyanide is a radical, is equal to -3. So implies x is equal to +3. This is second one. X is equal to how much? It is +3. So this is second one. Like that you can find oxygen states. NiF6 taken 4 minus, this is +2 state, straight away you can say. And CrO2Cl2, it is +6 state. So answer is D. Because CrO2Cl2, 2 oxygens, 4 and 2 chlorines, -1, 6 total, -6 and +6. Because the sum of the oxygen states of all the elements is equal to 0. So answer is definitely chromium oxychloride. This is the compound which is formed in chromic chloride test. Chromic chloride test is a form. Chromic chloride test, this is the compound it is forming. That is chromium dioxide dichloride. That is chromium oxychloride. Chromium oxychloride, the name of this compound is. So answer is definitely D option. Let us check now. Yes, it is D. Next question. So like these questions you are expected for the entrance exams. So very, very important, all these questions. In the standardization of sodium thiosulfate, this is called sodium thiosulfate, using potassium dichromate by iodometry. This is the titration method, volumetric titrations. The equivalent mass of potassium dichromate is very, very important. So what happens when sodium thiosulfate reacts with potassium dichromate? It reduces sulfite ions to S2O3 2 minus to sulfate ions SO4 2 minus. It oxidizes. So sulfur oxidation state, here it is +6 oxygen state, and here it should be +3. +3 changes to +6. So potassium dichromate on reaction with, in the standardization of sodium thiosulfate using potassium dichromate by iodometry. Iodometry, the equivalent mass of potassium dichromate. So potassium dichromate, equivalent mass of potassium dichromate in acidic medium or neutral medium, it is equal to molecular weight by 6. Equivalent weight is equal to equivalent mass is equal to molecular mass by molecular weight by 6. So answer it should be, let us check the answer now. So it is molecular mass by 6. Very, very important. Next question number 6. Let us see. The basic character of transition metal monoxide follows the order. As we already know, metals in their lower oxygen states, metals in their lower oxygen states, metals in their lower oxidation states are basic in nature. So now they're asking decreasing order of basic nature. So that is chromium oxide, vanadium oxide, ferrous oxide, titanium oxide. So if you remember the numbers, that is vanadium, titanium, chromium, if you know the order, that's why I told you the atomic numbers of 3D and 4D are very, very important. So which will come first, that is more basic. Which will come last, that is less basic in the atomic numbers. So titanium, vanadium, chromium, iron, vanadium, chromium, titanium oxide and iron oxide, titanium, fire. So which is following the order? So that is the answer. And now the answer will be option C, because after titanium, we'll be getting vanadium, then chromium and ferrous oxide. So by this, what you can say, on moving down the group, the basic character decreases. On moving down the group, the basic character decreases in 3D transition elements. So the basic character decreases, the basic character decreases on moving down the 3D series. So this is the reason probably we can write. So titanium, then vanadium, then chromium oxide, then iron oxide. Because titanium after vanadium you'll get, chromium you'll get, then iron you'll get after manganese. Next question. Heating of ammonium dichromate formula NH4 taken by Cr2O7. Heating of ammonium dichromate produces very, very important reaction. Heating of ammonium dichromate produces what? So it is forming nitrogen, chromium oxide, and water. Ammonium dichromate produces nitrogen gas, chromium oxide, and water. You can see the reactions in the lectures. So ammonium dichromate formula is NH4 taken twice, Cr2O7 on strong heating forms N2 plus Cr2O3 plus H2O. H2O should be taken as 2H2O. So that total it becomes 4 hydrogens, 8 hydrogens. So it should be 4H2O. 4H2O, so that it becomes 7 oxygens. Now it is balanced. 4H2O. This is the reaction. Very, very important. So ammonium dichromate on heating produces nitrogen gas, chromium oxide along with water. Next question. The equivalent weight of manganese sulfate is half of its molecular weight when it is converted to, let us see now, simply you can check the oxygen states. So I automatically will get, what is the oxygen state of manganese in the manganese sulfate? It is +2. It is how much? It is equal to +2, because a sulfate is a radical, SO4 2 minus. So sulfate is a radical, it is 2 minus, so this should be +2. Is half of its molecular weight and it is converted into. So manganese dioxide, Mn2O3, what is the oxygen state of manganese here? It should be +3, because 2x minus 6 is equal to 0. And here it is +4. And here it is +7. And here it is +6. So +3, +4, +7, +6. So suppose if manganese sulfate changes to manganese dioxide, then equivalent weight becomes change in oxygen state. That is, equivalent weight is equal to molar mass by 2, because change in oxygen state is +2 changes to +4. If you take this, it is exactly equal, because molar mass by 1. And if it is taking for this, it is a molar mass by 5. And it's changing from this, it is by 4. So answer will be by 2, means half of its molecular weight. So definitely answer could be second option, that is B. So when they are given like this, simply you find the oxidation states of manganese in all the 4 cases. It's very easy to calculate oxidation state. So once you calculate oxidation states, wherever +2 is changing to +4, then it is exactly by 2. If it is +2 changing to +3, it is by 1, because difference is 1. Here difference is 2. Here difference is 5. And here difference is 4. Next question. Number of moles of potassium dichromate reduced by 1 mole of tin ions is 1 by 6, because potassium dichromate, already we know potassium dichromate, that is CrO2, Cr2O7 2 minus ions on in acidic medium changes oxidizes Sn plus 2 to Sn plus 4, and it forms Cr plus 3, 2 Cr plus 3. So here it is plus 6 state, and here it is plus 3 state, and plus 6 changes to plus 3, and 1 chromium, since it is 2 chromium, so it is 1 by 6. So answer is 1 by 6. 1 by 6. So it is 1 by 3, because here plus 2 state changes to plus 4. Yes, yes. 1 by 3 times, because only plus 2 changes to plus 4. So answer is A. It is not C. It is A. So like this equations also they'll ask in the examination. Which of the following electronic configuration would be associated with the highest magnetic moment? So another part, magnetic moment. How will you calculate magnetic moment? Mu is equal to root of n plus 2, n into n plus 2, where n is equal to number of unpaired electrons, So whichever is having maximum number of unpaired electrons, that is called the answer. Simply directly they are given, luckily for us, A 3d8. 3d8 means 3 unpaired electrons. N is equal to how much? It is 3. And in this case, n is also equal to 3. And in this case, n is equal to 4. And in this case, n is equal to 3 again, because it is 3d7. 3d7 means 3 unpaired electrons. 3d3 means 3 unpaired. 3d8 means 2 only. So here it is 2 unpaired electrons. And 3d6 it is equal to 4. So highest magnetic moment, which is having highest number of n. So that is could be n magnetic moment, because mu is equal to root of n into n plus 2. So answer is third option, that is C. Because 3d6 means the electron will be like this. Arrangement of electrons will be like this. So it is 1, 2, 3, 4, and 5 electrons. Sixth electron will start pairing up. So unpaired electrons 1, 2, 3, 4. So n is equal to 4. 3d6 configuration. 3d3 means only 3. 3d8 means say 6th, 7th electron, 8th electron, only 2 unpaired. And 3d3 means 3. And 3d7 means 7th electron will come, only 3 unpaired. So in all these cases, which is having highest magnetic moment, which is having highest value of n, that is having highest magnetic moment. So highest value of n will be for third option. So answer is C. Yes. So like these questions are most important. Please note it down. Next question. All zinc plus 2 compounds are white because Zn plus 2 has D10 configuration. Zn plus 2 has D10 configuration and the D substance is full. Zn plus 2 shows DD transition. Zn plus 2 has no electron in the 4s subshell, and Zn is a transition elements. Very, very important here. Zn plus 2, if you take into consideration, zinc atomic number is 30. So it is having the configuration, zinc configuration is argon 3d10, 4s2, and if Zn plus 2, if you take into consideration, it becomes argon 3d10, because 2 electrons from 4s is removed. Now Zn plus 2 has D10 configuration, the D subshell is full. That is first. Zn plus 2 shows DD transition. That's why it is exhibiting color, we can say. And Zn plus 2 has no electron in the 4s subshell. And Zn is a transition element. It is not a transition element. So only 1, 2, 3 options, out of which is related to this white color. White color is due to DD transition and D10 configuration, because it has no color. White color means colorless, we can say. So since it has D10 configuration and the D subshell is full, no unpaired electrons. As there is no unpaired electrons, says there is no DD transition. So answer is first option. First option, very, very important. Next question. Many transition metals forms interstitial compounds. The characteristics of these interstitial compounds are, so which of the two is correct regarding interstitial compounds? This we have discussed in lecture 2. So they have high melting points, higher than those of pure metals. They are very hard. They retain metallic conductivity. They are chemically more reactive than pure metals. So these are the 4 statements they are given, and continuation of this question will be presented in next slide. You can just see here. So next slide, only 1, 2, 3 are correct. What is 1, 2, 3? Let us see the previous slide. First one, they have high melting points, higher than those of pure metals. They are very hard. They retain metallic conductivity, and they are chemically more reactive than pure metals. So let us see now answers. Only 1 and 3 are correct. 1, 2, 2, 4 are correct. Only 4 is correct. So let us check the answer now. So answer is first option, 1, 2, 3 are correct. So they are more reactive than transition metals. They have high melting points and boiling points than transition metals. So all these points are very important. So this question explains all the properties of interstitial compound. So only 3, 1, 2, 3 are correct. First option. Very, very important. Please note it down. Next question. The compound in which nickel has the lowest oxidation state is very, very important. This question. So nickel has lowest oxidation. Generally, nickel has +2 state as well as +4 state. And in this +2 state is more stable. But lowest oxidation state in any compound is in metal carbonyl compounds. This we have seen in the 11th class. Metal carbonyl compound, the oxidation state of metal is 0. Metal carbonyl compounds. In metal carbonyl compounds, you note down the statement in your classwork. The oxidation state of metal is 0. The oxidation state of metal is 0. Example, NiCO taken 4 times, FeCO taken 5 times. So in these two compounds, the oxidation state of nickel is 0 and the iron is 0. So in metal carbonyl compounds, the oxidation state of metal is always 0. This point is very, very important. So answer is first option straight away we can say, because in all other compounds it is +2, +2, +4, +2. So this is +2 state. This is also +2 state. This is again Cl2P, so it is again +4 state. So answer is first option, it is 0. Lowest oxygen state. Lowest oxygen state, it is 0. Let us check the answer now. 100% should be A. Next question. So please note it down this question. And in metal carbonyl compounds, what is the explanation for this question? In metal carbonyl compounds, the oxidation state, the oxidation state of metal is always 0. Next question. Which of the following is are paramagnetic? Paramagnetic means they should contain unpaired electrons. The substance contain unpaired electrons. They are said to be paramagnetic in nature. They should contain unpaired electrons. So Zn plus 2, no unpaired, 0 unpaired, because N is equal to 0. Number of unpaired electrons is 0. Ni plus 2, Cu plus also 29 copper atomic number. So 4s1 is N is equal to 0. Fe plus 2, iron, it is having 3d5 configuration. So it has. And Na plus 2 also you can see, it is atomic number of nickel is 28. So 28 means configuration argon, nickel configuration. So you should remember definitely the atomic numbers. If you don't remember atomic numbers, 100% you will not get this answer. So atomic number of nickel is 28. So argon 3d, 4s2 anyway, it is 20. So 4s2 20, and here it should be 3d8. So 4s2 means 2 electrons are removed, so 3d8. It is having unpaired electrons because N is equal to 2 here. And for this iron atomic number is 26. Atomic number is 26. And it is argon 3d6, 4s2. So 2 electrons is removed, so it is 3d6. So N is equal to 4. But very important point is it is ferromagnetic in nature. Iron is a special case of magnetism. So that's why it is ferromagnetic in nature. So answer should be And if you take Zn plus 2, it is 3d0. And here also, sorry, 3d10. And Cu plus also 3d10. 3d10 means no unpaired electrons. 3d10, 3d10. And here it is 3d8. And here it is 3d. Again, it is 3d6. For iron, it is equal to 3d6. So the answer could be, for this answer, it could be B and D. E's are paramedic, so it is more than one correct option. So it is 3d8, 3d6. So which is having unpaired electrons, that is only paramedic in nature. Which do not have unpaired electrons, they are said to be diamantic in nature. So Zn plus 2 and Cu plus. In this answer, A, B are A comma B here I'm writing, so please note down. A, B are diamagnetic, whereas, sorry, AD, AC, sorry, is ACR diamagnetic. Option A and option C are diamagnetic because they have no unpaired electron, that is N is equal to 0. And magnetic moment is also, mu is also equal to 0 because it has 0 unpaired electrons. So AC are diamagnetic in nature and BD are paramagnetic because they contain unpaired electrons. So if they ask about diamagnetism or paramagnetism, we can find out number of unpaired electrons. Whichever is having number of unpaired electrons, they are said to be paramagnetic, and also very important, they are said to be colored. They exhibit colors, and these two are colorless. Zn plus 2 and Cu plus, Zn plus 2 comma Cu plus are colorless. So these 4 points are important. So for this answer to solve, you should definitely remember the atomic numbers. If you don't remember the atomic numbers in electronic configuration, 100% you will not get the answer. So that's why, as I told you many times, 3D series, 4D series elements with atomic numbers are the most important. So definitely you'll get a question based on electronic configuration. They can ask directly configuration, or they can ask the magnetic moment. They can ask number of unpaired electrons. They can ask whether they are colored or not, and they can ask even paramagnetic or diamagnetic or ferromagnetic. If they ask ferromagnetic, Fe plus 2 only. So that's why with the electronic, if you don't know the atomic numbers, you cannot write electronic configuration. And with, if you know the electronic configuration, you are able to answer all the questions. Very, very important concept. Please note it down. Transition metals and their compounds catalyze reactions because why the transition metals are used in catalyst. This we have discussed in general properties of metals. They have incomplete field desorption. They have a comparable size due to poor shielding effect by desorption. They introduce an entirely new reaction mechanism with lower activation energy. Anyway, if they are used as catalyst, definitely they are having lower activation energy. And fourth point, they have variable oxygen states differ by 2 units. So answer could be C, because they can form a good surface. Why it is C? Because metals have clean surface, which for which adsorption can be easily taken place. Metals are having, most of the metals, you can write most of the metals. Most of the, you please note it down in your class work. Most of the metals are having clean surfaces. Clean surfaces. Clean surfaces which can provide, which can absorption, which can absorption, in which absorption can take place. Absorption of reactants. It is used for absorption of reactants. If the reactants molecules come closer to each other, the reaction takes place faster. That's why more than as the reactant molecules are coming closer to each other, it leads to the lower activation energy. Lower activation energy. This we have discussed in chemical kinetics also. So metals produces a clean adsorption surface by which the reactions are getting adsorbed, the reactants are getting adsorbed, due to which what happens, the activation energy of the reaction gets lower, and due to which the reaction takes place faster. That's why most of the metals are used as catalysts. Next question. Vanadium Z is equal to 23 atomic number they have given. Luckily, generally they will not give this also. Forms an ion which has a magnetic moment of 1.73 Bohr magneton. The symbol of the ion will be, so 1.73 means root of n into n plus 2 is equal to 1.73. So when it could be possible, if you take n is equal to 1, 1 into 1 plus 2, 1 plus 2 it is 3, and the root 3 value is 1.73. So answer could be B plus, because only one electron, number of unpaired electron is only 1. If number of unpaired electrons is equal to 1, then only we can say it is 1 plus 1.73 Bohr magneton. And vanadium is vanadium configuration is what? What is the configuration of vanadium? You can just see here, vanadium atomic number 23 means argon 3d 3 4s2. And if you take vanadium plus, it becomes argon 3d3 4s1. So even we cannot say it is 4s1, so it has 4 unpaired electrons, so it is not correct. So let us discuss now this one. So this is n should be equal to 1, but here n is equal to how much? It is 4. So let us take, so if a magnetic moment, if n is equal to 1, then only it is possible. So in which case n is equal to 1, it comes, we'll see. So let us see, answer it is not B plus. So let us see B4 plus. This is very typical question, very, very important. So vanadium 4 plus if we take, then it becomes 3d3 4s 3d1 4s0. So vanadium 4 plus if you take into consideration, it becomes argon 3d1 4s0, because all the 2 electrons from s and 2 electrons from d will go off, so it will is only one unpaired electron. So answer is definitely B4 plus, not B3 plus and B2 plus also, because in this case n is equal to 1. So you have to write the configuration and then you have to decide the answer. So answer is D. As I told you, answer is D. So first order assumption is correct. That is root of n into n plus 1 is equal to 1. If n is equal to 1, then only magnetic moment becomes 1.73. If n is equal to 1, then only mu is equal to 1.73 Bohr magneton. So we have to identify by seeing the configuration where you will get n is equal to 1. In the first case, n is equal to how much? It is equal to, in n is equal to 3, because 3 plus 1, 4. First case, n is equal to how much? 4. Second case, n is equal to 2. Sorry, it is 3. Third case, it is 2. And fourth case, it is 1. So answer is n is equal to 4, n is equal to 3, n is equal to 2, n is equal to 1. So n is equal to 1 only, we have magnetic moment 1.73 Bohr magneton, because the mu formula is mu is equal to root of n into n plus 2. So answer is D. So please copy down. Next question. The correct order of increasing magnetic moment of the following ions. Again, we have to check the oxygen states. The correct order of increasing magnetic moment of the following ions. VO plus 2, VO2 plus, VO2 plus, VO plus. So in this case, the oxygen state of VO plus 2, let us see, VO2 plus is nothing but what? The oxygen state of, this is vanadium is X minus 4 is equal to plus 1. So X is equal to 5. And second case, VO2 plus, VO2 plus. So X minus 2 is equal to plus 2. So X is equal to minus 2 will go to that side, it is 0. So third case, it is VO plus, it is 1. So answer should be, which is having highest magnetic moment, that is number of unpaired electrons, that is having highest magnetic moment. So answer is 1 is less than 2 is less than 3. 1 is less than 2 is less than 3, because it is a plus 1 state, and 2 it is plus 2 state, and 3 is plus 1 state again. So 1 is less than 2 is less than 3, because in 1 it is X is equal to 5. So oxygen state is equal to 5 means, if X is equal to 5, I'll show you now. Here in the oxygen state of vanadium plus VO2 plus X is equal to 5 means 5 electrons of vanadium is removed. So vanadium atomic number is 23. So if you remove 5 electrons, it becomes argon, no unpaired. So in this case, n is equal to 0. Like that, you have to find n values for each and every case of VO2 plus and VO plus. So it should be definitely it is greater than 3. So answer is third option. So which is having highest number of value of N, that is having increasing magnetic moment. So first you find the oxygen state of vanadium. So in the second case it is 0, so it should be 5 electrons, and third case it should be VO plus, it is uh, x minus 2 is equal to 1. So it implies x is equal to 1. So x is equal to 1 means it is only 1 electron is removed. So out of argon 3d3 4s2, 1 electron is removed means 4s1. So it has n is equal to 4. In this case n is equal to how much? 4. So definitely it has more magnetic moment. So you have to find n values in each and every case after finding oxidation state of vanadium. Whichever vanadium is having more the value of n, that is number of unpaired electrons, that could be the answer. Next question. In which of the following species the color is due to the presence of unpaired electrons? Generally, the color is present due to DD transition and charge transfer phenomenon and even unpaired electrons. So in which of the following cases it has unpaired electrons? What is the oxygen state of manganese? It is +4. What is the oxygen state of manganese here? It is +6. What is the oxygen state of manganese here? It is x minus 4 is equal to -2. So x is +6. So if you take the configuration of manganese, +4 state and +6 state, +4. What is the atomic number of manganese? Manganese atomic number is 25. 25 means argon 3d 4s2, that is 20 and 35. So if removing 2 electrons, it is n is equal to 5. Mn4 plus means argon, Mn plus 2 is 3d, n is equal to 5. So Mn plus 4 means 3d3, argon 3d3 only. So it is n is equal to 3. Plus 6 state, argon 3d1. So n is equal to 1. So in all the cases we have unpaired electrons. Whereas here it is +7 state, no unpaired electrons. So it is 1, 2, 3 only. Answer is what? 1, 2, 3 only. And in 1, 2, 3, we have n is equal to 1, 2, 3 and respectively. Whereas in other cases, fourth case, Mn plus 7 means all the 7 electrons are removed. Once all the 7 electrons are removed, it becomes argon configuration. So no unpaired electrons. But still it is exhibiting color due to charge transfer phenomenon. Here this is due to charge transfer phenomenon. Charge transfer phenomenon from oxygen atom. Charge transfer phenomenon. Whereas here these are all due to unpaired electrons, because here a number of unpaired electrons is equal to, in the 3d3 n is equal to 3, so it is equal to 1, n is equal to 1, and here it is n is equal to 3, and here n is equal to 0. But still it is color due to charge transfer phenomenon. So answer is only one. First option, that is 1, 2, and 3. Very, very important question. So please note it down. If a species does not contain, remember this point, very important, I'm repeating here. If a species does not contain unpaired electrons, but still it is exhibiting color, it is due to charge transfer phenomenon. And the color of transition metal ions is due to charge transition. That is due to DD transition. Color exhibited by transition metals will be, it is due to DD transition and also unpaired electrons. So answer is first option. Very, very important, this question. So all the best questions we have discussed. Anhydrous FeCl3 can be prepared by the reaction of FeCl3 means iron in plus state. Iron with HCl in the presence of oxygen, ferric hydroxide with concentrated HCl, Fe2O3 with concentrated HCl, iron with dichlorine. So it is nothing but simple answer. It is iron with dichlorine, because iron oxide changes to FeCl3. So answer is first option. Straight question. Next question. Silver bromide dissolves in sodium thiosulfate. This is due to the formation of complex compound. So what is that complex compound could be? Very, very important question. So it is due to the formation of Na3AgS2O3 taken twice. Next question. The false statement regarding iron thioxide hydroxide, that is FeOH taken twice, is that it is a weaker base than FeOH taken twice. Correct only. But they are asking false statement. With concentrated KOH, it forms a complex K3FeOH taken 6 times. It gradually loses water and transforms into Fe2O3. It exhibits amphoteric properties, acidic ones predominating. So answer could be it does not exhibit amphoteric properties, acidic ones predominating is wrong answer. Which are the following will have the highest value of magnetic moment? This type of questions are coming so many times. So that's why this is very, very important. Highest magnetic moments, straight away we have solved this question. Which contains more value of N? More value of N, that is unpaired electrons. That is the answer. So in the first case, what is the oxygen state of VO plus 2? VO plus 2 oxygen state will be, it is X minus 2 is equal to plus 2. So in first case, it is 0. V is equal to 0. So, sorry, n number of unpaired electrons is equal to 0 because, sorry, this is not 0. Oxygen state of vanadium is 0. So, where we have 0, it becomes B5 plus. By B5 plus only. So, if you take B5 plus, sorry, I'll just show you now. When you get vanadium 0 unpaired electrons, if you take vanadium atomic number is 23. So, if you take argon 3D3, 4s2. So it is in plus 5 state. Should be plus 5 state where n is equal to 0. The oxygen state of 0 means vanadium is 5. So 100% answer is A. Here n is equal to 5. So please note it down. Next question. So VO plus 2, sorry, answer VO plus 1. We are discussing about VO plus 1. So find the oxygen states and find the values of n. So you'll get the answer. Next question. So with this, we have completed all the important questions. So let us see now. Now let us see. This is the last question we have discussed. So VO plus 1 is having highest value of magnetic moment because VO plus 1, the oxygen state of vanadium is. Let us see the oxygen state of vanadium in VO plus 1. So VO plus 1 is only one electron is removed because vanadium in plus 1 state. So one electron is removed means VO plus 1 if we take into consideration. So the oxygen state of vanadium is X is equal to X minus 2 is equal to 1. So X is equal to plus 3 means 3 electrons are removed. So 3 electrons are removed means number of unpaired electrons will be equal to 2. So n is equal to 2 means it is having highest. So this is the important topics in D block. So in D block elements, what you are going to study, that summary of the chapter, simple it is. Simply study general properties, all the general properties and preparation properties of potassium permanganate and potassium dichromate. Only 3 topics we have in this chapter. So it's very, very easy. Listen and do maximum number of questions, like this type of questions are very important. So with this, I'm ending this session. With this, I'm ending this session. Thank you all.